Hello everyone. In this video we're going to be looking over new functions from old functions, and the one we're going to be concentrating on are composition of functions because that's the one people have issues with. But we're going to start with just a simple one. Well, this one here obviously is very simple. We're just adding the functions together, and so the first one, let's call that a. F plus g will just be equal to the root square root of x plus square root of 4 minus x squared. And we're pretty much done there. B f minus g is equal to square root of x minus square root of 4 minus x squared. And you're done. And then f times g is equal to square root of x times the square root of 4 minus x squared. Of course, you can multiply these, and so you get 4x here minus x to the 3. And then the last one is f divided by g, and that would be divided by 4 minus x squared. And you can make it into one big square root if you want to. It doesn't change the value. So that's minus x squared. Those are the answers. This is not what people have issues with. People usually have issues with composite functions, and I did too in school. As a matter of fact, I did not understand it when I took Cal 1, but it was a brief subject, brief topic, and I studied it on my own and got to understand it. It's very easy. So we're going to go into that. Okay, let's look at this example here. It says if f of x is equal to x squared and g of x is equal to x minus 3, find f of g and g of f. One would think that f of g and g of f of are the same, but it's not the same. So let's get started. So we're going to write f of g as f g of x. Essentially, g of x, f is a function of g of x. And then now we have something that looks like this already, and that's this. F of x is equal to x squared. We have g of x in here now, and g of x is equal to something, is equal to x minus 3, so we're going to write that in here. So now, instead of having just x in here, we have x minus 3. So if f of x is equal to x squared, then f minus 3 of f is going to be equal to x minus 3 squared. And that's the new function. And then now we're going to do the same thing for g of f. So you have g first, and then the f of x goes in here. So you're going to treat the f of x first. Essentially, g is now a function of f of x. So we're going to rewrite it like we did above. We know f of x is something. It's equal to x squared. We're going to write that here. And we also know g of x initially is x minus 3. Now, g is now x squared. So what we're going to do is we see that this x appears only in one place, minus 3. And this is g of x squared. And so it's going to appear in one place, but it's going to be x squared. Now, minus 3. And you're pretty much done. Let's look at another example. Okay, f of g will be equal to f g of x. And then we know what the value of g of x is. It's this, so you go ahead and put that here. And now, this is now our x. And this obviously looks like this because it is. So the x here, what we did when it on the other side was we just took a square root of that x. So now this is now a new x, and all we're gonna do is take a square root of that on the other side. 2 minus x is now a new x, and then we take a square root of that. So it's like taking 2 square roots. So that's 2 minus x. Okay, right, like that, which is the same thing as this, 2 minus x. G of f is equal to g f of x. Now g is a function of f of x. So g, so f of x is equal to the square root of x. I'm going to put that here. So now this function and this function are the same. And we know here, well, all we did was we took a square root and subtracted x from the 2. So now this is now our new x. So all we're going to do is this. Writing this function with respect to this. So it's 2 minus, well, we just wrote the x here because that's what we have new here. We have x, the square root of x. And so we're going to write the square root of x. And that's it. I mean, there are many ways of rewriting this. You can decide to write it like this. It's the same thing. The next one is f of f. And that's f as a function of f of x. So we're going to have this f, and f of x is equal to x. I mean, the square root of x. And this f of x is equal to the square root of x. Now x is equal to the square root of x. And so all we're going to do is we're going to write our x. And then we're going to take the square root of the x, just like we did before. So this is equal to, we write this for x1 to the fourth. And then g of g, kind of do this sometimes to almost confuse a person, but once you understand the concept, you might be confused, but you'll be correct yourself or find your mistake quickly. So g of x is the square root of 2 minus x, which is equal to, so this is now our new x. So what we did here is we took the square root of 2 and subtracted our x from it. So here, we're going to take our square root. We're going to have our 2. And now we're going to subtract our new x from it, which is square root of 2 minus x. That's pretty much it. I mean, you can write in so many ways, but uh, that's the answer right there. So that's it. The next one, we're going to go to ones that are more confusing. The reason why I like Stewart's Jim Stewart's textbook is that they highlight the difficult in core questions, or questions that they think might that has a lot of twist that might cause confusion. And so if you want to know if you understand something, you can just go to the problems and look at the highlighted ones. So what we're going to do next is we're going to go to the highlighted questions and solve those. And if you understand those, then you pretty much understand composite functions. Thank you for watching. Have a wonderful day.